Now it's time for our last speaker, Joe Sanford. Joe is assistant professor in the School of Agriculture and Hub-funded faculty at UW Platteville, so native Wisconsin, and he earned his BS, MS, and Ph.D. in the biological system engineering at UW Madison, where he focuses now on the biochar application and for agricultural nutrient management. So let's welcome Joe.
All right, thank you. My name's Joe Sanford. I'm with the University of Wisconsin-Platteville through the Dairy Innovation Hub. And today I'm going to talk a little bit about some research that started here at UW Madison as a postdoc with the Dairy Hub, and it's kind of followed me through my years at UW Platteville. And so first thing, this crowd, I probably don't have to talk too much about it, but manure is a resource, not a waste. So when you think about livestock sustainability, manure has a lot of those essential nutrients, those micronutrients that we just talked about, and we use that manure then to fertilize our crops that are needed to produce the feed to feed our cattle. And in current times where fertilizer prices, particularly nitrogen fertilizer prices, are in a lot of flux, this has become more apparent. Manure has nitrogen, and as fertilizer prices soar, we can use that nitrogen on the farm and also use it off the farm as well as a fertilizer source to reduce the cost of that supplemental fertilizer. Now with that said, manure does have some challenges, particularly with the variability of manure. So if you go from one farm to the other, manure is going to vary quite a bit. And even within a farm, it's going to vary as well. So when we store manure, what's going to happen is we're going to have stratification, which is essentially those solid particles are going to go to the bottom, the liquid's going to be more at the top, and that's going to create quite a bit of difference in that, that nutrient content of that manure pit. All right. Now, we can go out and we can agitate that manure storage. All right. So we can go out, we can agitate it, and this is going to mix up that manure, create a little bit, or create less variability in that manure. But there are some challenges with this. One is proper agitation. How many farms follow the guidelines of a half a minute per animal unit? It depends on the farm. All right, so getting that agitation, having that done before sampling is not always done. And also it is a fairly significant cost as well. And so I apologize here. I gave this presentation to a Canada group a few weeks ago, and it says Canada. That's actually US dollars, not Canadian dollars. I forgot to move the CAD, all right? But it is an expensive cost when you think about agitation cost for that manure storage. And so just to kind of put this in a little bit more perspective, this is a project that was done when I was a graduate student. Dr. Rebecca Larson here at Madison was working on it. And they essentially had 16 farms. There's only 12 shown in this figure. But they basically had these farms sample manure throughout their storage emptying process. And the farms are told to go about their agitation process on the farm. And what we can see here is this is the total Caldol nitrogen, so TKN. And what we can see here is that some farms, when you look at that variation, they don't have a ton of variation. So for example, farm 1 here, from the various samples that were taken during this pump out, it ranged from 19 pounds of nitrogen to 25 pounds of nitrogen per 1,000 gallons. Right? So not a huge difference in that variability. When we look at some of the other farms though, like farm 9 for instance, really seem to have some issues with their agitation process, a lot of variability in that TKN, right? That, if you look at that samples pulled through pumping, that's 7 pounds per 1,000 gallons up to 34 pounds per 1,000 gallons. So now when we think about nutrient management, those dollars start to add up in terms of the fertilizer cost of supplemental and how we handle this, all right? So this variability exists. Some farms are better than others, but it is still there. And so how can we improve the system? As I mentioned, variability is an issue. Agitation is costly. Another big issue is lab results. Lab samples are expensive, and they're also not instant. Some labs will get you manure samples back in about a week. Other labs might take a month or two, all right? And so it is not an instant result that we are getting. And so what we've been looking at are different technologies to help us provide near instant results in terms of that manure analysis so that we can better apply those manure nutrients, better track those manure nutrients to improve our overall system efficiency. So I'm going to talk about two systems here. The first one I'm going to talk about is the Harvest Lab 3000. So those of you who may not be familiar with this system, it's a system produced by John Deere. And it's actually used for quite a few different purposes. And one of the underutilized ways that this system can be used is for manure analysis in real time. And so how the system works is it has a near-infrared spectroscopy sensor. All right, it shines a light at that manure. It gets different readings back. And in real time, what it can do is it can predict nitrogen, ammonium, phosphorus, and potassium. All right. From these measurements, we can break these up into direct and indirect measurements. So nitrogen and also dry matter is a fairly direct measurement from the spectra that we get. And then phosphorus and potassium, we have to rely on some more predictive models using other characteristics of that manure to predict that phosphorus and potassium. And so I just kind of wanted to highlight how this system kind of looks for people that may not have ever seen this system installed, but that yellow box there on the manure tanker up at Arlington, this is our Harvest Lab 3000. It sits inside this box. It sits on basically the manure slurry discharge line. So as that manure is coming out of the back of that tanker, it's going through this sensor. Again, that sensor's taking thousands of readings per minute, and then translating that, that data to the cloud and also to the display within the cab. One thing that is important to note is that the Harvest Lab 3000 can't do all of it by itself. We also need to have a flow meter as well installed, so that flow meter right before there is necessary. So inside the cab, this is kind of what the system would look like. It'd give us our information according to our flow meter, the gallons per minute being pumped out. We'd have our working width. And what we can do in here is we can track our nutrients. So in real time, we can look at what the ammonium, nitrogen, potassium, dry matter, phosphorus is. But we can also we can set targets. And so we say we want to apply a certain volume of manure or certain pounds of nitrogen per acre. We can use the system to set that. And we can also set limits as well. So if we are restricted on phosphorus, we can say we don't want to exceed this specific phosphorus value. All right. And so this is just a little example of the data that we get from this system. So Tyler Liskow, who works for Becky Larson here, last year he went out, or 2 years ago he went out and applied manure. And what we can see here is the far our figure there, that's basically our applied rate. So that's the gallons per acre that we are applying. And then we have our nitrogen, phosphorus, and potassium maps as well. And so what happened here was that Tyler went for a lunch break. He came back after halfway through the field. It's been a few hours, and the agitation system had moved over to the swine pit at Arlington. And we can see in real time that this system was able to pick up differences in that manure as that manure started to settle out. So the nitrogen started to go down, the phosphorus and potassium started to go down. And so this is just an example of how this system could potentially be leveraged to improve our system efficiency. So our research has primarily focused on our sensor validation. How well does the sensor work? How accurate is it? How much can we trust it when it comes to this analysis? And we're also interested in looking at how can we leverage this sensor for potentially nitrogen management, for phosphorus management, and things like that. So our main study, which was funded by the USDA, was looking at basically using this sensor and comparing it to kind of business as usual at a farm. So what we did was we had strip plots and we had different nitrogen rates that we wanted on each of these plots, and we either used the sensor to apply that manure to meet that nitrogen rate, or we looked at last year's manure data and we figured out what the gallons per acre should be to meet that nitrogen rate. All right? And so we compared these. We looked at 3 different nitrogen rates to apply to these plots, and we're able to compare then the performance of these two. Now this is the data, and the first thing I want to highlight is the lower part here, looking at the NIR data. So our NIR plots here, what we can see is when it came to application, our desired application rates are up there, the 92, 110, and 138 pounds of nitrogen per acre. And when we look at the actual applied over here, we can see we were within 25% or so of that desired application rate. Right? So the sensor was able to provide us with fairly accurate applications of nitrogen. Now, we were all excited because we saw the fixed rate, what we did. Now, we're a lot off. But for some of you that might have sharp eyes, our planned application right here, our actual application right here, we had an issue that day with the flow control in the tractor when we were doing just the fixed rate. And so we actually ended up applying a lot more manure than we were supposed to, all right? So if you looked at kind of the application rates, right, fairly similar. So we were able to have similar results to that kind of fixed rate in terms of that manure application and that nitrogen analysis. Now, one thing is we also did a study. We were very interested in looking at the performance at different pumping speeds because different tankers pump differently. We also wanted to look at the phosphorus and potassium as well. And so what we did is we went out, we pumped at a few different speeds, looked at the accuracy, we sent this off to a couple labs that were MAP certified and looked at the differences. And what we can see here is for the John Deere Harvest Lab system, pretty consistent in terms of that nitrogen analysis, both for ammonium and total nitrogen. If you compare this to kind of general variation of lab results, it'd be fairly similar, this kind of difference between these two labs. But a big thing that stands out is phosphorus, not so hot, neither was potassium. And so this kind of goes back to that direct versus indirect measurement, where here we're relying on a lot of different things to predict that phosphorus and potassium. And the sensor, this was back in 2024, just wasn't quite there. Right? We're currently, Tyler's probably out there today running this again with an updated calibration, and we're going to see what those results bring back. So, last thing I just want to kind of touch on is an emerging sensor that I've been working with. And so we've been working with a company out of Denmark for the past year, which has a system that instead of NIRS, they use nuclear magnetic resonance instead to predict manure nutrients in real time. And so this is an example of their system here. This is a lab-based system that we have down at Platteville. And essentially put the manure in, it pumps the manure through. We have a big magnet inside of here. And then what it does is it'll provide us with nitrogen, total nitrogen, ammonium, and phosphorus values of that manure. And so with this company, what we did was we actually participated in the United States. We have the Manure Analysis Proficiency Program, the MAP program. And our lab actually participated in this program last year. And we were able to pass that Manure Analysis Proficiency Program. All right, so we were up against about 50 other labs, and we were able to, with our system, be able to provide results that fit within the MAP program's criteria for becoming a certified lab. Now, one caveat here is this system can do liquid and slurry manure samples. It cannot handle solid samples. And so one caveat here is with the solid samples, our lab actually did all the wet chemistry ourselves, but all the liquid samples were analyzed by the system. So this was a promising, it kind of helps us, our phosphorus, we passed that, and so it kind of gives us an idea that maybe this other system might be able to provide us with some better results. And so we're currently working with the system, we're trying to make some different jobs. So we've collected manure from quite a few different farms, dairy, swine. We're using the system to pump manure through, analyze it. We're sending it out to 6 different MAP certified labs to compare the results. And that work is currently ongoing. The company asked me not to share those results today because we're not done with it yet. But what we've seen is, in terms of the analysis time, we're kind of doing their, what they do on their field systems, that test range, and we were getting very accurate nitrogen and ammonium results. Phosphorus, still a little work to go with that as well. And so last thing is this system too, it hasn't been mounted on a lot of tankers yet, but the company is working on it. And so it'd be very similar to the harvest lab, but instead of kind of instantaneous readings as we're pumping out, it provides us more of a tanker to tanker variation of those nutrients in that manure. And so I'm currently working with the company. We're trying to get one of these at Pioneer Farms so that we can start looking at kind of on tanker and how those might, how the system might work. And so with that, thank you. I'd like to shout out to my research team. Becky Larson at UW-Madison has been on this project since the beginning as well. Her research engineer, Tyler Liskow, does a lot of the field work for us, and Isaac Linsmeyer over there, he did a lot of the NMR work in our lab this past year with NanoNord. So thank you.
Thank you, Joe. We have time for a couple of questions.
Thanks, Joe. I had a question about the field application versus the NIR assessment, and I was wondering, could you just reiterate or say again, did you end up looking back at that field application data and rescaling based on the % of nitrogen to see like how comparable you actually were, or scaling up the NIR, or?
Yeah, so yeah, with that variation with our applied rate, yeah, so we did do some back calculations to look at, based on what we had and what should have been applied, they would have been fairly comparable in that situation. One thing I'll add though is our field, I mean, it's strip plots on a 12-acre field. We're trying to get those done in one day, the agitator's going, so we didn't have a lot of variation in that manure during that time, and so that's one thing we're gonna be looking at, trying to get some funding to kind of look at how we might be able to leverage the sensor, maybe to reduce agitation, right? Mix it not quite as much and then use the sensor to apply in real time to do that, since we do have fairly comparable nitrogen values kind of to our business as usual.
Thank you for the great talk. How do you handle the vibration in the field? Is it for the NMR especially?
Yeah, so so how we handle the vibration in the field, so that's a big challenge with NIR, is going from a lab scale where you have very controlled environments to outside. And so the company that produces the sensor recognizes that, and we have slight differences in temperature that could change results and things like that. One thing I didn't mention is they call it a skateboard. They have a special pipe that goes on there that holds the sensor that tries to minimize some of those vibrations. Is it perfect? No, but it does help minimize it a little bit. But yeah, it's a good question.
We have one more question.
Thanks. This is not my area, but interesting technologies. But the new one that they are trying to install into the truck actually will only measure the whole tank, right? So it will not allow to do kind of the same as John Deere precision application, basically, right?
Yeah. Yes. So that is, so the difference between them, the NIR, it's reading every gallon of manure it comes out, it's having an analysis for. The NMR would be a little bit of a different approach. And so it'd be a tanker to tanker variability, essentially. So the idea would be still we could track the differences, but maybe just not within that one tanker. And so when you're going out, you're applying 10,000 gallons, maybe depending on your tanker size. How variable within that tanker is it gonna be? That's another question that we're kind of interested in to see, can the NMR provide that precision still? maybe not having as many readings, but still providing that sensor to sensor and being able to track what field it goes to, where it was applied, and be able to update our nutrient management plans based on that. So it's a little bit different of approach, but based on the data we've seen from the NIR study, we don't see a lot of variation oftentimes within the tanker. And so we think this might be a suitable alternative to improve that phosphorus, particularly those measurements.
Well, thank you so much to all of our speakers today in the session.